15.4 Perpendicular bisectors of triangles. Homework problems. Before we begin with some problems, let us review some vocabulary. The word perpendicular means to form a right angle. Right angles measure 90 degrees. You can see here that the right angle is marked with a little tiny square. The second word is bisect. Bisect means to cut or divide into two equal parts. Very important, it's two. You can see in this cookie how the cookie got cut into two different parts. The cookie was bisected. The last word we need to review is midpoint. Midpoint is a point found in the middle of a line. So if you can see here, M would be considered the midpoint of the segment AB. And M is doing the cutting in half. That point is the part where this segment is getting cut into two equal pieces. The first piece is AM and the second piece is BM. Those two are equal now, or congruent, and that is why they are marked with this tally mark here. They are both marked with the same tally mark. Now let's put the vocabulary together. A perpendicular bisector are the red lines. The red lines are your perpendicular bisector. So let's go to take a look at that. OM3, this is a perpendicular bisector since it's forming that 90-degree angle and it's cutting this segment A1, A2 in half. The second perpendicular bisector would be from O to M1. Again, it's forming that 90-degree angle and it's cutting this segment A2, A3 in half. That's why these are marked with one tally mark. These here you can see are marked with three tally marks. Now let's go take a last look at the last perpendicular bisector, which would be from O to M2, again in red, and you can see it's forming that 90-degree angle. And at the same time, M2 is the midpoint, so A1 all the way to A3 is being cut in half. That means A1 is congruent to M2 and A3 is congruent to M2. So those red lines are your perpendicular bisectors. Now let's go look at AO1. Okay, because we have the red lines, which are perpendicular bisectors, that causes from O to A1 to be the same distance as O to A2, as the same thing as O to A3. So those three blue lines are actually equal in measure. They are congruent to each other. And you can see that they're marked with 4 tally marks. Each one is marked with 4 tally marks. Our last part of our problem here is the bisecting, so the segments. So you can see that A1 is to M3, A1 to M3, this one here, is congruent to A2 M3. Also, A2 to M1 is congruent to A3 to M1. And last, A1 M2, A3 M2. Those are all congruent to each other. So you can see that the midpoints are cutting each side in half. Now one more thing. A1 M3 is not equal to A1 M2, and it's not equal to A1 M1. Each side is its own segment and it's cut in half by its own midpoint. So you can see that these two here are congruent. A point of concurrency is the point where 3 or more lines intersect. So you can see here that these three lines are intersecting at point P. Now, the circumcenter of a triangle is the point where all three of the perpendicular bisectors meet. So those were the red lines we saw in our first picture. Now you can see in our picture down here, if you have an acute triangle, that means all of your angles are under 90 degrees. Then your circumcenter, where your perpendicular bisectors meet, see, 90-degree angle, okay? They form the 90 degrees and they cut your segment in half for each of the sides. These three lines are meeting inside of the circle when it's an acute triangle. On a right triangle, all of your perpendicular bisectors actually meet on the triangle itself. So if you look here, triangle ADC has all the perpendicular bisectors meeting on this point, and that point is actually on the triangle. For an obtuse triangle, now an obtuse triangle is a triangle that has one angle inside that's more than 90 degrees. So if you can see here, this angle here, okay, angle ACD is actually 107, and that's more than 90 degrees. Since that is happening, then your circumcenter, where all the perpendicular bisectors meet, that will be found on the outside of the triangle, not on the triangle or not inside the triangle. I will start with number 1, and they're asking you to build the circumcircle of this triangle. Now the circumcircle is the circle that surrounds the triangle and it touches every vertex. You can see here that this circle is too small for this triangle, so I'm going to make it smaller. And there you go. Now a good thing for you to do is to actually measure. So we measure this segment here in blue and find out what the midpoint would be. And you can use that as your center of the circle. You can do that for each of the triangles that you were given. Before we get started with number 5, it is a very good idea for you to go to the picture and mark what you know. You already know some things are congruent because we have perpendicular bisectors. Now, they mention here that ZD, which is this one here, ZD, is, and ZE and ZF are perpendicular bisectors. Now, by you knowing that those are the perpendicular bisectors, you actually know that these two were bisected. These two here bisected. These two here are bisected, which means they are congruent. And lastly, these here are congruent also. And let's put 4 so that we can know which ones those are. Okay, so now we have everything marked. And also it's a good idea for you to put in the measurements. So let's take a look at DZ. DZ is here. That one is worth 40. So let's put 40 right there. And ZA, which is this one here, ZA, is worth 85. And the last FC, which is this segment here, is 77. So let's go mark that one with 77. Okay. Now, if we take a look at our problem, they are requesting from us that we find ZC. Now, ZC is here. Now, we know that that one is congruent to AZ. So I wrote it here. Z is the circumcenter of the triangle ABC. That's this one here. And here's your triangle ABC. So ZA is congruent to ZB, which is also congruent to ZC. And therefore, since I know ZA is 85, I also know that ZC is also 85. Now, so I gave one of the answers. The second answer is for me to find out AC. So AC is this whole entire side. Now I know half of it. Now I know these two are actually equal. So if this one is 77, which is FC, and AE is also 77, I can add 77 plus 77. Or I could take 77 and multiply it by 2, which is actually what I'm going to do. F is the midpoint of AC. F is the midpoint of AC. So AC is equal to double whatever FC is. Now I know FC. FC is 77, so I'm going to substitute 77. And 2 times 77 gives me 54. So that means that the measurement of AC is 154. I will work on number 10 with you next. Okay, in this problem, PK is the perpendicular bisector of AB. PL is the perpendicular bisector of BC. And PM is the perpendicular bisector of AC. Tell whether the given statement is justified by the figure and select the correct answer for each lettered part. AK is equal to KB. Now this would be justified. This is justified because PK is the perpendicular bisector of AB. Cuts it in half. Next, I'm going to do C. On C, it says that PM should be equal to PL. Now, that one is actually not justified. It is not justified because those are two different perpendicular bisectors. The perpendicular bisectors are not necessarily congruent. Now, the measurement from the point to each one of the vertices, like this, P to A or P to B or P to C, now those are actually congruent. But as far as the perpendicular bisectors go, which are these three, I don't know that they're actually the same length. Lastly, I'm going to help you with D. You still need to finish B and E on your own. So for D, it says here that BL is half the size of BC. Now that would actually be justified because we know that PL cuts BC in half. So I know that BL and CL are congruent and that BL has to be half the size of BC. So that's why the half is here in front of the BC. So if I take the whole segment BC and I cut it in half, I'll get BL. The next problem I'm going to help you with is number 12. Graph the triangle with the given vertices and find the circumcenter of the triangle. Now, This problem is asking me to graph the triangle using the points they gave me. And when I'm done, I have to find all the perpendicular bisectors so that I can make the perpendicular bisectors cross each other. And once I find that intersection, I will have found my circumcenter. Here are the steps once again for this problem. Number 1, plot the points Q, R, and S. Draw the triangle, which is the triangle QRS. Find the perpendicular bisectors, and then find the point of concurrency, which will be your circumcenter. Okay, we're going to plot the point 3, 4. Then we're going to plot the point 7, 4. And lastly, we're going to plot the point 3, -2. So all of my points have been plotted. Next, I connected all the dots to form my triangle. Now I have to draw the perpendicular bisectors. In order to draw the perpendicular bisectors, I need to measure the side. So I'm going to measure this side, which has 1, 2, 3, 4. And I need to find out what is half. So half is 2. That means my bisector is here. I drew a red line, cutting that one in half with a 90-degree angle. Now I need to find out how many are on this side. 1, 2, 3, 4, 5, 6 units. Half of that is 3, so 1, 2, 3. That means I'm going to draw my perpendicular bisector going this way. Okay, I drew my perpendicular bisector, and now I need to find out where my dots, my lines concur, or where their point of concurrency is. Before I go on, I'm going to mark off that I did my perpendicular bisectors. And now I need to mark my point. So the point where the 3 of them concur is right here. Now that point, now I can find out that I found my perpendicular bisector, my point of concurrency, which is my circumcenter. This point here is called your circumcenter. And that point is at 5, 1.